All right, hello and welcome to week 11 of Info 655 Digital Curation and Preservation. This week is entitled Access for Robots, and it's called that because we're going to be looking at the flip side from Access for Humans, which is all about interfaces and how we can make them work better for humans to work with. And we're going to look a little bit on the infrastructure side of things. What are the tools by which the information gets delivered to those interfaces? How is that tool something that can be adapted and built upon to build better interfaces or to build new interfaces to interact with other systems? That gets at this idea of APIs, which we've talked about a couple times during the semester. And this week, we're just going to work purely with this idea of APIs. So let's get into it. So the key points for this are, number one, understanding what an API is. And that is that it is the language by which various systems interact with software. Those systems can include you as a programmer or a developer or a user of some kind manipulating various requests of a system in order to get the response that you want. And the language by which you make those requests and the way that you get those responses back, that is the API, the application programming interface, because you are doing a little bit of programming. And I'll show you some examples of ways that you might have been doing this that you might not have thought about as programming, but are interactions with an API. Secondly, the API, it is something that exists for every system. There is, not just one API. This is a characteristic of different systems. It's a characteristic of different pieces of software. They can exist at many levels, and it's something to be aware of that when somebody is talking about an API, it has to be, you have to understand what context they're talking about, which system that they're talking about, because it might not be the API that you work with because you work with a different system. So these are not all the same things. And then finally, one of the other things about APIs is that I said that they're contextually dependent, that they depend on the system. But that doesn't mean that every system has a different API. And in fact, once you get about to this process of defining the language of how you ask for resources and how you get responses back, well, that API can become a standard that you can make other systems be able to speak with. So many systems can use a similar API, a similar set of requests and responses, and thereby make it easier for other people to interact with those new systems. So we'll see a few examples of that. But as always, let's look at the gigantic diagram. So this week in the gigantic diagram, we are in our third week on access. So that is focusing in over here. And last week, there were some good questions. Where does accessibility fit into a functional diagram like this? And the big emphasis is on the idea that when it comes to accessibility, because it is one of those things, just like all systemic biases, that is systemic and is made worse by the fact that all the systems support those biases and reduce people's access to collections because of them, we want to approach it in a systemic way. So we don't have a function that says more accessible. What we do is we look at these different functions that we have, the ability to coordinate somebody's access activities, to look for collections or to request collections, the ability to generate collections for these people as they need it, the ability to deliver that information back to a user. We need to look at each of those and say, how do we make this more accessible? And I think that's a very good framing also for looking at this API stuff. Which one of these things is the API? None of them. The API is potentially something, one API or multiple APIs is something that is imbued into every one of these functions. So when you look at the arrows passing between these functions, for example, from coordinate access activities to perform queries, what you see is there is the arrow on one side is making a request to perform queries, and then on the other side, it's delivering a response, the query response. So depending on your system, there is likely an API that is actually making that possible, that somebody sends a request that says, do you have any pictures of cats? And you get a response back and it says, yes, we do. Here's some information about that. Or potentially it says, no, we don't. I don't have any pictures of cats. Maybe it says, the server isn't working and I can't tell you if we have any pictures of cats, or various other things. But there is a programming interaction between one system and another, a search function and a database function, and they are exchanging information over there. And similarly, you can look at other arrows on this diagram, and there's lots of things that are saying, here comes a request and here comes back a response. And generally, what you would love is if this is a purely digital workflow, that would all be driven by API interactions, that there is a program out there that is making the request and receiving the response and delivering that information to the next function in the line. That doesn't mean that it has to be something that is software. There are lots of places where you don't have the resources, or the material that you have is not in a digital system. And so the request is something like a call slip, and the response is a page going into the stacks and pulling down that box and then delivering the box to the person. That is also a very valid interpretation of this framework. But when we're looking in a digital sense, APIs become something that is the way that a lot of these more technical people are thinking about things. And you can tell that they were thinking about this when they wrote this, because they keep saying request and response over and over again, which is our keyword for, these people are interested in APIs, and they think about the way systems interact with each other because of that. So let's look at some of these functions and say, okay, well, how do they interact with this API idea? Well, the first thing that I want to point out was that we have the deliver response function. So this is the endpoint, supposedly, for when you have material that you want to give to a user. So putting that box on their desk or putting that image into their browser. And it says, hey, look, that can take place in a lot of different ways. But the important thing is that it is taking a response from all of the other requests that you're getting from the user, from your database system, from your storage system, things like that. And it's packaging that all together and saying, this is what we think the user wants and the best that we can create, and is delivering that to that user. Now, it can do that online. It can do that offline. So we can do that in a reading room, or we can do that on a website. But we are taking a request and we're delivering a response. And this is a very common thing for an API. And we're going to sketch out what that can look like. But I don't want to just say, if you don't have an API, you're not doing this right. Again, that is just a thing that is good to know about and something that you're going to hear about at conferences. And it's a good idea to be able to hear those three letters and to be able to interact with it. But your access system does not have to be a top-of-the-line technical whiz-bang thing. There's lots of ways that you can create access that don't rely on this sort of systems-level programming on-demand access strategy. So things that you can do are things like, generating all of those access files that you want and keeping them on a hard drive in your reading room, and then, having them available for a researcher when they get there, instead of saying, make a request to our website and we will deliver the image to you on demand. You could also do something like setting up a workstation in your reading room to access extremely restricted materials, or to provide other types of environments. I have here linked the Emory University Salman Rushdie Workstation YouTube video, which is a very interesting experiment in which they have a Mac in their reading room. And when you sit down at that Mac, you can open up an emulated version of Salman Rushdie's Mac computer, as you can see in this window. And so you can browse using the software and the files that Salman Rushdie used. And it'd be hard for us currently to build a website to do that. That's not a default feature of something like Omeka or Mukatu or any of the things that we've looked at. To be able to emulate a workstation like this, it's probably easier to set up a workstation in your reading room and say, if you need it, this is available, but otherwise we're not going to go through the effort to automate this and to scale this up to like an internet resource. Finally, another thing that you could do, so instead of responding to each individual request, you could have something that you just say, generally, there are users that are interested in this kind of like bulk data, and we don't know exactly which slices of our collection that they're interested in. So why don't we just make the whole thing available as a bulk download, and thereby they can figure out what exactly they want. So we're going to give them the first step, and we're going to say, because you know how to work with data, we're going to say it's your job to filter this down and figure out what you want. So an example there is the Met Museum, which dumps its full collection database, well, at least the parts of it that they would like to make public, once a month as a very large CSV. And they've been doing this for 5 years. And if you ever want to do research on the collection, on the objects from a very distant kind of digital humanities point of view of the Met Museum, you can get the CSV and you can do a lot of work there, a lot of data work. So you have those types of things, and just as a couple of examples, here's another way that we're doing access to a digital object without using an API, or at least it doesn't seem like it. This is the emoji collection at MoMA, and you can see what they have here is a printout of all the original emoji as they were published in 1996. But then, actually, there is an API hidden in here. So because there are so many emoji and they are in electronic form, you can say, the most authentic version of seeing an emoji is to see it as pixels on a screen somehow. And so what they have here is this light up screen on the right. And that light up screen actually shows you multiple emojis. It scrolls through all of the other options for the images, but you can also direct that screen to look at very specific things. So you can use this touchscreen panel on the left. You can scroll to a specific category and touch that. And as you go to that category, the screens on the right will show you the emoji that are part of that category. And hidden in that interface is an API. There is, once you touch that category on the left, you are making a request. You're saying, I would like to see the emoji associated to this one category. And as a response, there is a program somewhere sitting on a computer somewhere that says, I received this request to see this category, and therefore I will pull up the images associated with that category and I will display them on the screens on the right. And so you are manipulating that API. You're performing a programming action. You're saying the screen on the right should display this stuff, but you're doing so by touching some pre-generated categories on the left. And that is getting us into this idea of what is an API.